Okay, this is right. Okay, now you see the various forces acting on a car, a generalized system where a car is actually taking a inclination, trying to accelerate against the inclination. You also got a hitch here, which actually pulls the trailer, and we have considered even the aerodynamic drag forces acting on the center of pressure here, and this is the center of gravity through which the inertial forces and also the weight acts, and these are the reaction forces on the front wheel. This is the reaction force on the rear wheel. Okay, and the center of gravity is at a distance of B from the front wheel and C from the rear wheel, and L is the wheelbase of the car. So let us try to find out what is the reaction force WF. So that is the weight on the front wheel when a car is accelerating. So we are trying to generalize the system now. So now, in order to actually find out WF, we should actually take the moment about the rear axle or the rear wheel at this point. So about this point, there are several forces which are actually trying to rotate this car like this, which you can call it as positive. If they are trying to rotate the car in this way, you can call it as negative. Okay. Now let us see the first force here, WF. Now about this point, will it actually try to rotate clockwise or anti-clockwise? This force. Clockwise. This is at what distance? L. So we'll write this as plus WF into L. So let us not mark it as into, because that will confuse with X. So WF into L, that is plus. So this is done. Okay, and then let us take this value dA, which will be acting like this. So that means about the rear axle, there will be a force which is just what a perpendicular distance of how much? HA. So that is positive again, because it's trying to rotate this clockwise. So that is also plus. dA into how much? HA. And then we have got a force which is actually acting like this. So this is actually M into A, but M is written as W by G. Okay, so this is acting like this about the rear axle. So that is it is trying to rotate the vehicle in this way. So what is the force and what is the distance? Force is W by G into H. So that is also plus. W by G into H, which is the center of gravity. And then there is one force here. There's one force, let us consider again there is W sine theta, which is again acting backwards due to inclination. Okay, this is again acting at the same height H. So that has to be again considered as positive, negative? Positive. Plus W sine theta into H. Okay. So now what are the other forces left? So then the reaction force due to hinge. Because of this hinge force which is trying to pull it backwards, will it create a clockwise or anti-clockwise movement? Clockwise again. So clockwise. So that is RHX plus RHX. I'll try to write neatly. So RHX multiplied by what distance? HH. And then there is one force due to, because of the hinge, there are two forces on the hinge. One going downwards, one pulling backwards. This is at a distance what? This is at a distance which is actually called as DH. Distance to the hinge from the rear wheel. So the force is like this. About the hinge point, the distance is equal to RHZ multiplied by DH, small dh. And then see, we have considered this. So we are done with this, we are done with this. Okay, are we done with this? No. All the forces are done except this. So this force W cos theta is acting like this. Is it acting clockwise or anti-clockwise? This is the only force which is acting anti-clockwise. This is W cos theta. This is acting at what distance from the rear wheel? It is acting at a distance of C. Okay, so the car is actually not flipping backwards or diving forwards. it is balanced on the road like this. So that means the sum of the moments are 0. So you need to equate this to 0. This is the equation that you have to remember for a very generic case. And suppose, depending upon, based on the cases whether the car is accelerating or decelerating, you can change the directions here. Okay, so now with this equation you can solve for WF, because they would have given you dA, they will give you HA, they will give all these values. Only what is not given is weight on the front wheel. The weight of the car would be given, all these parameters of the car would be given. They will ask you what is the weight on the front wheel for a scenario. What is the scenario? Can you tell me? So what is the scenario? A car going downwards? A car going upwards. Car decelerating? No, accelerating. Okay, so this is for car going upwards and accelerating. Suppose if I say car going downwards and decelerating, what is the change in equation that you will do? Suppose if it is going downwards, suppose if the car is going downwards like this, then this W sin theta will act forward. Instead of like this, it would act forward. Then this W sin theta has to be taken as negative. And